Hi, Dr. Shet and Alan. Finally, we are done with developing the feature which we thought of integrating with the Kibi, the semantic features. So we call it as Semantic Kibi. Yeah. Let me walk you through what we have developed. So the visualize button. We have integrated this feature with the pie chart. I'm selecting an index, let's say an article. This is with the Elasticsearch results. So we have got these many uh, results, 13,243. So let me select this split slices. Yeah, we know that we have built on this filters aggregation. Here we have these many aggregations within this bucket: histogram, terms, filters, and all of these. So the one which we have developed is the entities aggregation. But before that, let me show you how these filters work, so that we have a background of how it's working and what modifications we have made to the Kibi. So yeah, let's select filters, and yep. So here we have this filter one. Uh, Let us give hello, and yeah, you see, uh, earlier there are around 13,243, and that uh, we see that the count is 10 here with the keyword hello. So it searches within all the Elasticsearch results and fetches and searches for the given keyword hello, and it fetched around 10 such keywords, 10 hello keywords. So let me build upon this and add one more filter and see how it compares with these keywords. Let us, if I give nice, yeah. So nice, uh, the keyword nice has been repeated for 29 times in the Elasticsearch in the article index, which I have selected for the Elasticsearch index. And here the hello stands at 10, and it really gives the comparison of what percentage of nice when compared with hello. So you can add how many ever filters we would like to add, and we can just have a comparison. Good. Yeah. So here again it says hello, and this is good. Oh, good. Good percentage is around 85%. And here to the right you see the legend. If you just scroll over it, it just highlights the one which we hover over it. So yeah, the point to understand here is we already know that these are just hello keywords. This is merely a text. This is nothing but the hello text and nice text and good text. So it uh, strictly searches the whole index, article index, with this keyword good, nice, and hello, and nothing more. Nothing is involved other than mere search text. Yep. So keeping this in mind, let me show you how we have enhanced this, uh, and using adding a new aggregation entities. Yeah. Let me go for split slices, and let me take a new visualization so that we get a good feel of how everything goes. Let me take the article index again, and yeah, here we see we get 13 to 43 results, and split slices and entities. Yeah, the moment we select entities, we are having this one. So this input, like, it is optional. I mean, like, we are currently not using it. there are some dependencies which uh, but we are not choosing this anymore. So here you have two input boxes. One is keep typing to select entities, and synonyms are populated here. So uh, yeah, currently the Sparkle query which we are using here is like we have hard coded it. For example, we have got two queries in the backend, namely entities query and synonyms query. Here you see entities query, and here you see synonyms query. So uh, yeah, so this is the Sparkle query which we are using for this synonyms query. And yeah, if you see the entities query, we are grabbing all the classes, and the synonyms query, it says subclass of asterisk mark and all this. So it says we have this to be replaced, and the class here. So what it does is, if we don't give any class, it takes the default class as this to fetch the results. So let me show you what results it has fetched. The synonyms query, because I've given a default class as natural cannabis here, it fetched all the synonyms for the given class natural cannabis. And here the it is an entity query which populates all the entities contained within the given uh, the Sparkle query. Like this Sparkle query should we have to give in such a way that it fetches all the entities, the main class. And the this one, it fetches all the subclass of the given main class. So yeah, so here if we keep typing, we see all these main classes appearing as a drop down. Yeah, so we have, computer is a bit slow. Yeah, so let me yeah if I scroll down, uh, this autocompleter number of results are limited to around 600. So I still see this dbpedia related classes, but if I go here to the down, I have some noises.org classes. To the down, see here I have this noises.org classes. Let me take this noises.org class cannabis to show a real example. Control C, and let me type here so that it fetches all the synonyms. So the moment I pasted it here, yeah, I just pasted it here, and we observe that uh, it has populated the all the synonyms here means the subclasses, the Sparkle query corresponding to this, and yeah, yeah. So all right, so let me add one more let me give CRA. So the moment I paste it again, so it populates the corresponding input box with all the subclasses, the synonyms. So uh, so these are all the representations for this main class. So what we need to understand here is like yeah, so when we meant this main class, it is a representation of all these synonyms. So a single, it's kind of a single keyword is represented by all these keywords, so we get a larger depth of results instead of mere text. Let's see, I would like to add one more thing. uh, Cocaine, add filter. Actually the response will not be this much slow. My laptop is getting too much heated. The it has become much slow. It's my laptop specific. Uh, it is a bit slow. That's the reason you observe that it's a bit slow. And then yeah, we are ready to see the results. So let me click on those. Yeah, that's cool. So here we see it's comparing all these different buckets, each slice being a representation of a class. For example, if I hover over this, it says me cocaine, and it's a combination of after two hyphens you see coke, comma, blow, comma, rock, and heart. So internally we have ORed all of these words. If I would like to show you the coding behind this, if you see this entity.js, so we have used this OR operator. So Elasticsearch really understands this OR operator and fetches all of these keywords instead of a single keyword. So if we are put a cannabis in the filters, it would pick only the text which contains cannabis. But here now we have got all these keywords, we have ORed them and sending it to the Elasticsearch results. So it fetches all of them. So here we have got around 118 for all of them, and for cannabis we have got 28. So it says like we have odd all of these, and it corresponds to 18.79%. and let me see with SCRA, it stands at 2.01%, and it has odd all of these things. So we could again just hover over this and see what all keywords have involved in this, and similarly this and this. Yeah, so yeah, here I've compared all of these, and we could change the queries here. We could change the queries here to fetch the uh, companies list as the main entities, and the synonyms could be, for example, if it is Microsoft, it could be MSFT or Azure, or like what all technologies, what the main representations of the Microsoft, and similarly Apple and Google. We could just have a comparison of these, and yeah, and also we could use this for the drug comparison, like the side effects when compared with one drug to the other, and we have many real-time benefits. And yeah, this is it. uh, we have also got this code in the GitHub, and uh, yeah, Dr. Chetan Dallin, please let me know your comments, and please let me know, are we good at this point to showcase this to Siren Solutions Kibi? And yeah, please, what do you feel? Please let me know if you feel of any modifications, and any suggestions on other real-time examples to show a demo to them. Thank you.